Hi, everyone. My name is Janessa Diane, and I am the Events Marketing Manager here at LucidWorks. Thanks for joining today's webinar, Accelerating Data Science with Fusion 5.1. In today's webcast, our speakers will be diving into what's new in LucidWorks Fusion, our AI-powered search and discovery platform for digital workplace and digital commerce applications. Before we get started, I want to orient you to the widgets you're seeing on your screen. The slide should be front and center and the media player on your top left if you're on your desktop. The media player is broadcasting the audio for today's webinar, and it will also show the video clips we'll play during the demo portion. Make sure your volume is turned up to hear the presentation. If you have questions throughout the webinar, please feel free to enter them in the Q&A box. We'll have time at the end of the session to answer the questions that come in. And be sure to check out the resources box on your bottom right for links to learn more about the Fusion 5.1 release. As a reminder, today's presentation will be recorded, and the slides and recording will be sent to you after the webinar. Today's presenters are Justin Sears, VP of Product Marketing at LucidWorks, and Sanket Shahani, Product Manager of AI. In today's webinar, we'll do a brief intro to Fusion and the latest release of 5.1. We'll also do a deep dive into Fusion's Jupyter Notebook integration and show you a demo through video clips on how to deploy machine learning models with Selden Core. At the end of the webinar, we'll leave time for questions that came in from the audience. And without further ado, I'll pass it over to Justin to kick off the intro to Fusion.
Thank you so much, Janessa. Great to be with all of you today. Do want to remind everybody that we do want your questions, so send those in the Q&A application in the On24 portal. We released Fusion 5 at our Activate User Conference in September of last year, and I have a hunch that many of the folks on this call might have been with us there in DC. That seems like a long time ago now. We're very excited about this new version, 5.1, because it delivers more of the cloud flexibility and data science toolkit integration promised by Fusion 5.0. And so today, Sanket's going into that last part in depth on some of the benefits for data science workflows. Before we get there, just a reminder, maybe for some of those on the phone that don't know much about Fusion or LucidWorks, like I said, many of you have been using Fusion for years, but for anyone on this webinar who's new to Fusion, I'll talk a little bit about how our products help your team better understand content, better understand users, and better deliver digital workplace or digital commerce solutions at scale. So on the understanding content, we help you understand content better by indexing vast amounts of structured and unstructured content. Our parallel bulk loader uses the power of Apache Spark to connect to any data source and index it in Apache Spark. As Fusion indexes content, it applies machine learning and natural language processing to cluster and classify documents, use NLP to recognize named entities like products, people, and places, tag parts of speech, and analyze sentiment within text. And Sanket's demo will highlight this data ingest and preparation capabilities. Because we understand content at index, the content can be used to match to a user's query intent so that Fusion can provide the most relevant results. Now moving to the right a little bit, Fusion also helps you understand your users. These users generate millions of valuable signals as they interact with the platform. And those signals help our clients uncover connections between different logical entities and different users. Fusion uncovers connections by using technology such as semantic knowledge graph that calculates the relationship strength between various entities and understands how they are related to the content. And Fusion App Studio helps companies create rich, purpose-built applications for different types of users so they can get the answers they need within the appropriate user experience. And finally, Fusion delivers AI-powered finding at scale by allowing you to connect to any data via pre-built or custom-built connectors, APIs, templates, or data pipelines. So that's on the product side. We also offer customer success support. So LucidWorks Customer Success Manager ensures continued success after launch through ongoing touch points and measurement of desired outcomes. And for complex knowledge management deployments, we offer advisory services on Fusion machine learning models. So that's a little bit about how we do it, but let me go into a little bit more depth on the technology just to get you ready for Sanket's demos. There are three, at LucidWorks, we know all about the challenges of ML-powered finding. We know those are complex because we began working on them 12 years ago. You saw the build I just did. All the stuff in the middle is things that we've been developing as a company for more than a decade now. And we did that so that the end user experience for our customers is a little bit more streamlined and simple to understand. So we begin with the data of all sorts on the left-hand side. That could be system-generated, human-generated, or application-generated. And in the beginning, when that data comes in, we do data ingest and prep, and we're using a lot of machine learning at that step. A lot of what Sanket shows will be that first step, the data ingest and prep. We do storage and search. That's based on open source Apache Solr primarily. And then we do intent prediction, again with machine learning. When users interact with the system, we look at the signals they've been sending, and the system understands how to predict what they're looking for and to match that with the data that's in the corpus in Fusion. I also mentioned app creation. We have an app studio to create new and different applications. All of that delivers on the far right solutions for digital workplace and digital commerce that personalize the experience of data discovery, product discovery, what have you. And so if we break it out into more detail, I won't go into this because I do want to save plenty of time for Sanket, but as I mentioned, a lot of his remarks in his demo are going to be focused on the data ingest and prep. So he'll talk about natural language processing, named entity recognition, parts of speech recognition, things like that, and then also document classification, anomaly detection, clustering, topic detection. Those general ideas will be a lot of what Sanket is going to go more in depth on. So before we move over to that and talk about solutions in a little more detail, Fusion 5.1, we released it about a couple weeks ago now, and the Fusion 5 branch is really about making Fusion cloud native. So it was re-architected in 5.0 for cloud native microservices architecture, and that's orchestrated by Kubernetes. So whether you're running Fusion in the public cloud or as a managed platform as a service by LucidWorks or in your data center, you can take advantage of these capabilities. If you're running in a data center and you have Kubernetes in your data center, it's just like running your own private cloud. So some existing customers, when they heard about this announcement, said, oh, no, I'm running in the data center. Does that mean I don't get Fusion 5? Not at all. All you need is Kubernetes, and you can take advantage of that dynamic microservices capability. And with that, going down the list here, auto-scaling policies help you dynamically manage resources. We can do that with much more pinpoint precision in Fusion 5.1 than we could in earlier versions. Native support for Python ML models, that's most of the demo today. You'll see that. And then, of course, easy integration with any data science toolkit of your choice. TensorFlow, Scikit-learn, Spacey, Jupyter Notebooks, which we'll show today, ... And it unfortunately, it wrapped a little bit here, but Spark streaming for signals is something that's brand spanking new in 5.1, and we're really excited about how that makes those really fast workflows with Spark integrate very easily with Fusion. So that's enough on the background. Let's get to the good stuff, and let me turn it over. Oh, sorry, 2 more slides before I turn it over to Sanket. So what that all means technologically is for our digital workplace customers, they can deliver a hyper-personalized workplace. And what that means is they can deliver workplace applications with a consumer-like experience. If you're like me, maybe you've had the experience where you have your coolest apps on your phone or on your laptop at home, and then you get to the office and maybe you have to set all that good stuff aside and use applications that seem like they're 5 to 10 years old. We break that paradigm really with our digital workplace solutions because they do take care of that personalization, that dynamic content delivery in a very consumer app type of experience. We also allow workers to discover insights for their job that have context and an awareness of their role, their past behavior, etc. We allow for successful cross-functional adoption of applied machine learning. So all the machine learning that Sanket's going to be highlighting in the demo, that comes shipped in Fusion already. You don't need to build it separately. And it trains on the signals coming in from your employees using the workplace solutions. And then, of course, the big thing is that this hyper-personalized workplace solution allows employees to be more engaged, more collaborative, and keeps them around longer working for you to do great things. And then, of course, we offer commerce solutions. Again, personalization, real-time relevant search results. So we know that every search is a unique experience and should take into account the context and the person doing that search so that results are different and in tune at every moment. Proactive recommendations with machine learning work on day one. As soon as you turn on the platform, all those signals coming in from your shoppers or your consumers are available to train the models. And we deliver that machine learning and that machine intelligence at scale across millions and millions of clicks and user sessions. But merchandisers also have knobs and levers to control that experience. It's not just that the machines take over. It's really a beautiful fusion, pardon the pun, of human intelligence and human experience with machine intelligence that comes under the hood with Lucidworks Fusion. And finally, lots of customer insights come in, and our customers that run commerce on Fusion, they get all those signals from their customers. They get to use those. That's different from some others that offer this type of platform. You get those signals to use in other parts of your business, maybe supply chain, maybe product development, maybe product naming. All of that stuff that your customers are sending you as they use Fusion, you can use that for other parts of your business. So that concludes my segue. Let me turn it over to Sanket, and let's hear about Jupyter Notebook integration. Sanket. Sanket, you might still be on mute. Oh, there we go.
No, I'm good. So Jupyter is one of my favorite tools and also one of the most widely used tools for data exploration. It is also the favorite of many data scientists. Therefore, Fusion now tightly integrates with Jupyter Notebook and Jupyter Lab. So users can choose whatever they are comfortable with. If they are comfortable with the direct notebook experience, they can use that. Or if they prefer using the lab, Jupyter Lab, they can do that too. So Fusion 5 is based on a microservices architecture, and therefore various components like Solr, index pipelines, UI, Zookeeper are all microservices. In this architecture, Jupyter Notebook runs as an independent microservice deployed on the analytics node pool, so that it doesn't interfere with the real-time search traffic load. So the Fusion 5 deploys across 3 node pools: the system node pool, the analytics node pool, and the search node pool. Nodes in these pools are dedicated for their specific function. Since Jupyter's scope is that of an analytics tool, it is deployed on the analytics node pool. The Fusion Jupyter service is natively capable of talking to the Solr collections in Fusion, and no extra configuration is needed. Users can directly start using it. This service should be used for deployment and testing, but not for running production loads. Once you are ready to run a production job, you should use Fusion's jobs framework. Also, Jupyter securely sits behind Fusion proxy. Therefore, users need to log into Fusion to access Jupyter. Users would access the endpoint via Fusion URL/Jupyter. The Jupyter endpoint is where people can interact with the Jupyter deployment and create different notebooks. Various language kernels are also supported, while the most popular one still remains Scala and Python. And the Fusion Jupyter service is also capable of running embedded Spark for heavy data processing or exploration that you might want to do. Fusion Jupyter service can be used to explore data from Solr, import and export data to and from Fusion to other storages like S3 buckets, Google Cloud Storage, Azure Blob Store, or any other database that you might be using internally. It can also be used to run Fusion SQL, which is an optimization Lucidworks has built on top of Spark Solr. Currently, some developers are using this tool to develop and test custom SQL aggregations that power the type-ahead search experience and also certain types of recommendations. Now let's take a look at an example usage of using Spark to explore, pre-process, and export data from Fusion. The data we have in Fusion is customer behavior data showing which documents were clicked or purchased for a given query. Since Jupyter is already connected to Fusion, we can easily start interacting with the data. Specify the collection, zookeeper, and the query you want to run, and the fields that you want to load. So what you are seeing here is once you run the single line command, which is something like spark.read.solr, that's all that is needed to be done. After that, you have loaded the data in Spark as a data frame. And in the last cell, you can see there are some examples of the sample documents of query and document pairs. So after you have loaded the data as a Spark data frame, everything that you can do in Spark, you can use Spark's native functions to do a lot of the pre-processing and dumping of the data. What we are doing here is we are doing some exploratory analysis on the data we have and trying to see what's the distribution of the departments that we have for all the queries. So you can see that there is a slight skew in the distribution where computers department is the most highly engaged department in the products catalog that we have. However, this is not an ideal data set to create a machine learning model. Therefore, we are going to use Spark's functions to create a balanced data set out of this to train a machine learning model. So what you see in the highlighted line here is we are using Spark's inbuilt functions to sample this data set and create a balanced data set for usage. Here you can see that now after sampling, we have roughly about 10,000 records for each department in the data. In the final step, we need to export this data. And to do that, we use this one-liner command, which is, again, a Spark native command, something like classifier data.write.parquet, and you can pass in your S3 location here. Now, you can configure Jupyter to export data to Google Cloud or any other storage that you prefer. And we will be using this exported data in the next demo to build a classifier and deploy it in Fusion. Switching gears here, let's take a look at the Fusion model service and what it is built for and what is the main purpose behind it and how it works. Today, one of the biggest challenges data science and machine learning teams face is integrating their machine learning models with production systems. Very often, these are two different systems and require integration work and maintenance. That creates an additional burden for the DevOps teams. And this challenge is across all domains and very much manifests within the document discovery and search domain. Today, data scientists and ML engineers work closely with search developers to push the conversion needle further and further. Fusion's Data Science Toolkit integration is an integrated ML model service that allows easy deployment, scaling, and integration of machine learning models focused on search applications. In short, your ML models live within your search tool, which is one of our differentiators in the search industry. Fusion integrates with Selden Core, which is an open source framework and is very actively maintained, and there is a very vibrant community around it. The process to deploy models in Fusion is rather simple, as Fusion handles the complicated part of it. First step is to train a model. Second is to package it up as a Docker image with all the dependencies. Third is to deploy it in Fusion which is a form-based schema that needs to be simply filled out. After that, the final step is to integrate the model with the query and the index pipeline. Let's talk a little bit about the workflow. The workflow for a data science team would be to develop a model and then purchase it to disk along with any dependent objects like your tokenizer, embeddings, etc. Next, you have to package it up as a Docker image, which consists of the prediction logic based on your model. This logic will change, like how you want this model to be doing its own predictions when a new document or a new query comes in. Then you have to package these dependencies based on whatever frameworks you're using. If you're using TensorFlow, NumPy, scikit-learn, etc., you have to package all of them up along with the model object themselves into a Docker image. Once you have the Docker image ready, you can push it to a Docker repository to which Fusion has access. If it is an organization's private Docker repository, Fusion needs to be granted access to it. It needs to be done only once and is a single-line command in Kubernetes. After you have set that up, you can use Fusion to deploy, scale, and integrate the model. Let's clear out the terms query and index pipelines. Query pipeline in Fusion is a set of stages that processes user queries and returns back the results to the user. An index pipeline is a set of stages that processes an incoming document and stores it for future searches. The documents can be anything ranging from PDFs, web pages, or product catalogs. Let's look at some of the components in Fusion that make the model integration possible. ML models are immutable Docker images that are deployed and scaled independently. Users can have multiple versions of the model deployed without worrying about the interference. Users can deploy multiple versions of a model, tag them appropriately, and publish them. Fusion will have no problem in deploying those. For example, you can develop a classifier version 1.0, then another classifier version 1.1, and also run an experiment with them by deploying them simultaneously. Since these are immutable and all the dependencies are local to the model itself, there is no interaction between these two. The next component is the Selden Core Ambassador API. It acts as a load balancer and balances the requests between different model replicas. Performing at scale is very critical when you have hundreds of incoming queries per second. There are two ways to solve this. One is keeping your model performant so that the return time per query is low, and the second is to have multiple copies of the same model parallelly processing the query. The load balancer plays a major part here in utilizing all the model replicas evenly and distributing the load across them. The next component is the ML service. The ML service is a Fusion's local ML service, which acts as a proxy and a bookkeeper of all the models available in Fusion. It also translates objects between the pipelines and the Selden Core API. Finally, there is the machine learning stage, which takes an incoming document or the query based on the pipeline in which they are added. These stages interact with the ML service using gRPC protocol. These stages also take the output from the ML model and use it in various forms to enrich the query or the document. The overall flow is that the document or the query flows through a pipeline, passes through the ML stage to the ML service. The ML service then sends it to the Selden Core load balancer, which then balances it across different model replicas. The predictions that the model makes are taken back to the same process and are used to enrich the document based on the use cases. Now that we have an idea of how the ML service works and what it is, let's take a look at a demo that is based on the data that we previously exported.
Great. Now as we reach this portion to show the demo, we'll be playing two video clips. And as a reminder, these videos will pop up through the media player on your top left. Once the first clip ends, please wait for the second clip to start and continue. This is a good time to remind you to enter any questions you have in the QA box and check out the resources on your bottom right. Please make sure your volume is turned up to hear the videos. Now let's get into it.
Okay, so the data that we have here today is an e-commerce data set that is publicly available. It is from a Best Buy store, and it was posted on the Kaggle online competition. So what that data consists of is two parts in it. One is the user interaction data, telling us like what users have interacted with what products for what queries. And then the catalog data itself, which is the ID of the document, the description of the product, and the name of the product. Now, what we are going to do is we are going to use the interactions data that we have exported from Fusion using the Jupyter service, build a class stage to classify the incoming queries. And to start with, we're going to look at how we built this model. So first, we are going to load the data set. In the previous demo, what we saw was we exported a classification data set to this location in the S3 bucket. So we are reading that data set back into a pandas data frame. And we are going to check on the columns that are there. So you see that we have the query, the department that the query belongs to, and the document ID. These two columns are of most importance to us right now to focus on. And just to take a quick look at the distribution of the data, it is still balanced the same way that we had exported it from Fusion earlier. Now what we're going to do is we are going to simply build a basic classifier using random forest. And what we're doing here is creating a train test split for the queries and the departments or the training data that we have. We are taking 75% of the data for training, keeping 25% for the test. Now you can look here that we have about 9,700 records for training and 3,200 something for testing. Sorry, my bad. It's 97,000 for training and 32,000 for testing. Okay, now to go and build the classifier, we are going to import a bunch of statements from scikit-learn and some matplotlib to just check on our models, to check the performance, etc. Some boilerplate code to just print the images. We're going to quickly check on the distribution of the data. Looks fairly good. Now we're going to use a TF-IDF vectorizer to convert the text into vectors and then create a random forest classifier on it. Now, once we create the classifier, we need to test the classifier. So we also have our test data set available. So we are converting using the same vectorizer that we used previously to convert the test queries into vectors, and then using the random forest model that we have trained here to create some test predictions. And then what we are going to do is we are going to use some confusion matrix and plotting to visualize how our classifier is doing. So we are using the y-test values and the test predictions that we just created from the random forest classifier to measure its performance. So taking a quick look at the classification, the concentration in the center means the classifier is performing good. It means that it is trying to classify maximum number of records to the same class. So appliances being classified as appliances and so on. So computer software gets classified as computer software. We can normalize this confusion matrix to see how the classifier is performing. So you can look at on an average, sometimes it's 84% accurate, sometimes it's 60% accurate on some classes. So on an average, this is about 75% accurate here. So the next step is, let's say we are satisfied with this model. We have to save this model to disk. So we use Pickle. We export our vectorizer and the random forest model. These are the two dependent objects that are required for working with this kind of a prediction model. Now we're going to quickly check whether it's saved. So we do a quick ls command and we see that both of these have been saved to disk. The next step is we have to package this up into a Selden Core classifier template. Now what that looks like is, so we create a prediction image folder specifically to store all the objects in it, and we copy the vectorizer and the random forest model to that particular folder. The next thing is we have to create a class. Now this is a standard Selden Core class. It's an open source framework template that anyone can use. Now, what you need to do is you need to simply specify two functions within that class. It's called the init function and the predict function. So the init function is a one-time initialization of the model and the dependent objects in it. So here what we are doing is within the init function, we are loading the vectorizer, and then we are also loading the model itself. So the vectorizer that we had saved earlier and the model that we saved earlier, we are loading them here. We are doing a dummy prediction, just an optional step to make sure that the objects are loaded properly. In the predict function, you have to pass in, and it gets a NumPy array, and it can be an array of strings, or it can also be an array of integers, floats, doubles, or numeric stuff. So what we do is we take this input and we pass it to the model to predict using the vectorizer. So we take this X as an input, which will be an incoming query. We use the vectorizer to create a numeric representation or a vector from this text query, and then pass that numeric representation to the model itself. And the model will give us back a prediction, and that prediction will be a class label, which could be a computer software. Let's say you pass in a query. So here you can check that if you pass in a query called Samsung fridge, it returns back that this is an appliance category. So now then when we use this at query time, we are going to use this additional information from the ML model to influence our search results by either modifying the query or doing something with it. Once you have this template, prediction template ready, or a prediction class ready, we have to package all of this thing into a Docker image. And really what we have to do is three simple steps. One is creating your dependencies file, which is the requirements.txt file. So at minimum, you need to add Selden core in it, which is the actual deploying engine. So it installs certain things onto the Docker image so that the Selden API can recognize this. The next thing we're dependent on is scikit-learn. So we add these two dependencies and basically create a requirements.txt file. The next thing is copying this prediction logic or the prediction class that we have for Selden core into a file. Now we have to make sure that the file name and the class name matches. That's the only restriction here. So we create a query classifier.py file and just pass in the entire prediction logic to it. Next, you have to create the Docker file. This is the last step for packaging up. So we start with the base Docker file code from Selden core, and then we have to only modify the model name. Now this model name has to match your class name and the query classifier.py file or whatever the Python file you create for the prediction. So these names have to match. And pretty much this will work most of the times without much modification. But if you need to modify, you can add multiple dependencies here. So what you see here is we are installing the requirements from the requirements.txt file. So the requirements.txt file that we created up above here, that gets installed onto the Docker image here through this command. And then finally, it runs the Selden core microservice with the model name, the API type, etc. So this is the Docker file that we create and store. So now to quickly take a look at how our prediction image folder looks like, it has a few files. One is the Docker file, the query classifier.py file, the requirements.txt file, and our model dependencies, which is the model itself and the vectorizer. The next thing you have to do is you have to build the Docker image. Now there are only like a few commands that you need to do in order to build this image and then tag it appropriately and push it to your organization's Docker repository. To build, you do Docker build, the folder that has all the contents in it, and tag it with whatever classifier name you want. Once this is done, we can check Docker images. We can also tag the image in the next step where you tag this Docker image, which is on your local machine, to the particular Docker repository. Now, ci-artifactory-lucidworks.com is our internal Artifactory repository, so we push our Docker images to it. So I'm tagging the local Docker image that I build to be pushed into this particular Docker repository. And then I finally issue the push command, and it's taking this Docker image that I built locally on my laptop to publish it to the Docker repository here in the CI Artifactory. So it's basically, you can see here that it has pushed the entire image. Now, after this has been done, what you have to do is you have to go to Fusion and actually deploy that model. Since this can take a couple of minutes, we have pre-deployed the model, and we'll only walk through how you would do that. So you would create a Selden deployment, create Selden core deployment model job, and that would look something like this. Now in this form, all you have to do is specify a job ID. It's an arbitrary ID that a user can put in. Specify the model name. Now this model name has to be the same as you have specified in your Docker file when you created it. The model name here has to match with what you use as the model name here, because that's what tells the ML service and Selden core to reference and deploy that particular model. Next is you can specify how many replicas you want. Then the Docker repository where the model resides, and the image name. In our case, it's query classifier 1.1, version 1.1. Now you can have multiple versions, you can deploy multiple versions, just change the tag. If you have 1.2, you can do 1.2, 2.0, anything the way you want. So that since there is no dependency between multiple models of the same type, you can have them tagged appropriately and there will be no interference between them. Then you specify the Docker like Kubernetes secret. Now this is the one-time setup thing that you have to do when you set up Fusion, and so that it has access to the Docker repository. Finally, you have to put in the output columns, and in the output column, you are basically saying whatever the predictions are being returned by the model, what do you want to call them? So we are going to call them department in this case. Now, once you run this job, it will deploy this, it will pull the model from the Docker repository and deploy it for us. So you can see that I have already deployed it. So we're going to have to do it again. We will add a machine learning stage here. Let's call it query classifier. We are going to choose the model that we have just deployed, which is the query classifier. And the input transformation script is nothing but a place where you can set parameters that need to be passed to your model. So in our case, it's going to be the query that's incoming. So the incoming query gets stored into the request object in Fusion, and to retrieve that we do request.get first param and then q. That gives us the incoming query, and that we assign that to the hash map that we have just created as x, and then finally return the hash map from this input transformation script. Now this map goes through ML service, and ML service will decode the hash map and then pass the input parameters to the Selden core model that we have deployed. Then comes the output transformation script. Now in the output transformation script, what you can do is you can pick the parameters and assign it back into the request object. So for example, here what we are going to do is we are going to override the incoming query with the original query plus a department level filter. So department is the column name that we have given to the output of this model when we created the deployment. So what we are doing here is now model output.get department. Now it returns a list. So we are taking the 0th element, which is the prediction itself, and then appending it with the original query with department colon the actual prediction from the model. So this will create an additional filter. So we should expect to see the output of this stage as a modified query here. So right now when you search anything, it is as it is. So once I apply something, I can change the query to Samsung fridge, and then now it attaches the additional department as appliance. If I do Samsung tablet, it will say computers. So the query is Samsung tablet and the department is computer. So this way you can modify the query that's coming in. Another example would be, so when you say Linkin Park music, it says that the department is video, compact disc, etc., and so on. So now you can build such classifiers based on your data to kind of increase the precision of your search results and kind of balance between precision and recall here. You can also use this as boost parameters instead of filters. And basically, once you get the output from the model, you're free to choose whatever you want. If you want to do any other complex operations, you can set up the JavaScript stage in Fusion. And in that JavaScript stage, basically you get a free-form text editor where you can modify the query, the request objects, or even the response that is coming back from Fusion.
All right. As we near the end of the webinar, thanks to everyone for entering in your questions. You still have the chance to enter them now, so please be sure to take advantage of that. Before we get started with the Q&A, here are some resources to help you learn more about Fusion. We have a blog post that gives you an overview of the latest updates in Fusion. And if you're ready to try Fusion on your own, you can deploy it in the cloud or in our sandbox through GitHub. And the links are here. And they're also on the links in your resource box on your screen. If you'd like to get in touch with us, shoot us a note at lucidworks.com/contact. Now I'll kick it over to Justin for the first question that came in from the audience.
Thank you, Janessa. We got lots of great questions, so I will we'll try and get through as many of them as we can. We're scheduled to go to quarter till the hour, but we might run over just a little bit. Hopefully that's okay. For the questions we don't get a chance to answer, we will be doing a blog post, and I'll make sure that we address these questions in that blog post. That'll be in a day or so. So let me take the first question. The question came in, can you elaborate on auto-scaling policies and Spark streaming in detail? So let me take those separately. Auto-scaling. The auto-scaling policies in Fusion are completely configurable and can be adapted to your specific use case. We rely on a variety of criteria, such as CPU use, memory pressure, 99th percentile latency, search rate, or a time-based schedule, so we can configure that based on your values for those items. If you anticipate increased load in a particular time window, your cluster can scale ahead of that event, and also ahead of that event in time for the moment that you anticipate. On the Spark streaming side of that question, Spark streaming is leveraged by a number of our customers to index hundreds of millions of documents in just a few hours, and they do that on relatively small clusters in terms of Fusion node count. We often use our Spark operator to stream about 15,000 documents a second to 3 node clusters. So obviously those nodes have quite a bit of RAM in them, and we've tuned Spark to work really well for the use cases that we focus on with regards to Spark streaming. So that hopefully that answers that question. Sanket, I've got one for you. Does the LucidWorks team use the data science toolkit integration internally?
Oh, yeah, that's a very good question. Actually, LucidWorks heavily uses this internally, and we have various models that are deployed on it. We have a deep learning-based sentiment analysis models, and also Smart Answers, which is LucidWorks deep learning-based question answering system in the current beta offering that is also deployed entirely on this framework. And we are also developing a semantic search solution to reduce 0 results for a search query, which would also be kind of deployed on the same solution. So all the out-of-the-box models, which are like Python-based models or deep learning-based models, they will all be running within this framework itself. So we use it internally, and it is also open for our customers to upload their domain-specific models.
Thanks, Sanket. Let me stay with you. I had a couple questions come in on Jupyter. Let me take the first one. Does Jupyter spin up Spark in Kubernetes?
No, Jupyter does not spin up Spark in Kubernetes. It runs Spark in an embedded local mode. So the scope for Jupyter is to be used as a testing, development, and exploratory tools. To run like it's a Spark job in Kubernetes, you should use Fusion's jobs framework and not Jupyter for it. But Jupyter can definitely run Spark in a local mode for exploration, and that's what we did in the demo that we had seen before.
Oh, great. So maybe that answered the second question that came out on Jupyter. Were you using Fusion Jupyter? Were you using Jupyter to develop the model?
So, yeah, sorry if that was confusing, but I was using Jupyter to develop the model, but that was on my local machine. It wasn't Fusion's Jupyter. So I wanted to replicate the workflow that a typical user might do, is where they export the data from Fusion, and then the data science team goes and works on it independently outside of Fusion to develop the model, test it, cross-validate it, etc.
Wonderful. Okay, let me take a couple more, and I'll come back to you. I have some more for you, Sanket. I had the question: how long will Fusion 4.x be supported? The answer is we are fulfilling all of our contractual commitments, and that's typically 18 months after the 5.x version was released. So that was in September. But we're working with customers on a case-by-case basis to move them to Fusion 5. And we might extend that contractual commitment given the COVID-19 outbreak and the impact that that's had on our customers. One other question that I'll take here was on GDPR, was whether we are compliant. The answer is we're not GDPR compliant certified, but we provide customers the ability to run their own hosts. So our customers can isolate data in those hosts and conform to whatever GDPR constraints they may have. Here's another one for you, Sanket. Can I use a Docker Hub repository instead of a private organization repository?
Absolutely. There is no restriction on which Docker repository you can use. As long as Fusion has access to it, it can be used.
And I think we have time for one more. And if we haven't gotten to, thanks everyone for sending in the great questions. If we didn't get to answering your question, I will note it, and we will attempt to answer that in the blog post. But the last question for you, Sanket, does Fusion manage different versions of the same model?
So the Fusion ML service is actually a model deployment framework and not a model creation or management framework. So Fusion can definitely deploy multiple versions of the same model, but it's up to the user to develop these models outside of Fusion and tag them appropriately. So for example, a query classifier 1.0 Docker image can be deployed along with query classifier 1.1, and these can be parallelly tested. So the deployment part is possible in Fusion. However, maintaining those images and managing, that's up to the user.
All right. Well, I want to respect everybody's time. I want to thank everyone who's joined, and it looks like many of you have stayed with us to the bitter end. I want to thank you, Sanket, for all the great insight into machine learning and data science in Fusion 5.1. And as a reminder, there are additional resources that you can read up on any of this content on, and we will be doing a summary blog post of this webinar that you can share with your friends and colleagues. That'll be available towards the end of this week or the beginning of next week. So with that, Vanessa, I think we're done. And again, thanks everyone for taking the time and spending the time with us today.
Thank you very much. My pleasure.
All right. Thanks, everyone.